Okay, I think we're back. Hope everybody had a good break. We're gonna do a little bit of firmware stuff today, so we haven't looked at digging into the firmware yet, so we're gonna do that a little bit. We're gonna stay on our Ender 3 here for today, and ours is an 8-bit board, so it's one of the older ones. So if you have a 32-bit board, then some of this stuff won't really make, or some of the process that we use will be different if you have a 32-bit board. So we're working on an 8-bit board for today. We're going to change out the board to a 32-bit. So if you do have one of the 32-bit boards and you want to do some firmware things, then just wait a little bit. Next week, maybe later this week. I'm not sure exactly when. Probably next week. We'll put a newer board in this printer so that we have that process to work through too. Now, why I'm doing this is I went and changed. Well, let's show you what I did. Let's show you. I went here to SaneSmart. I've got too many windows open. And bought these little, they call them SaneSmart 3D printer heat bed silicone leveling column, 18 millimeter by something. It's cut off the edge there. But these little guys, 18 by 4 pieces. So there's 4 of these little rubber feet that, let's see, you can kind of see they're 18 millimeter. They're just silicone standoffs. They're gonna fit, or actually I've already put them on. They fit. I don't know if we can see them, but they're right under here. Instead of the springs that were there, they're basically taking the place of the springs. So here are the springs. You know, there was a spring here and one on each corner. I replaced the springs, kept all the screws and the hardware and everything, kept all of that, and replaced the springs with these silicone standoffs. So what the difference here is, and there's not a whole lot of difference maybe, but you know, springs are pretty compliant. Now these are pretty stiff springs. They're not very flexible, but they do have some shakiness to them. Now the silicone does too. It is also compliant. It's not hard silicone. Some printers, sometimes you could even just print these. You know, you could print these in a solid material. They do have to stand up to heat though, because most printers have a heated bed that they'll be in contact with. So they do have to be a material that can stand up to that level of heat. So just plain PLA would get pretty close to softening if you printed some standoffs in PLA and put them under there. The Prusa back here is a solid mounted bed also. It uses, you can't really see down there, but it uses metal standoffs. They're really short. So what I was trying to do here is eliminate some vibration. So now the bed is pretty solid. They are still soft enough that I can compress them. You know, if I need to lower this corner or whatever, I can still compress them a little bit. They're just more rigid than what it was before. The other thing that does is that now I don't have quite as much leveling as I did before. You know, I can compress these some, but not a whole lot, not like the springs. There's something in between here. There are stiffer springs that you can replace these springs with stiffer springs and get kind of the same effect, but I'd never used these, so I wanted to see how well they work. They worked fine. They fit. I mean, they're literally just little cylinders of silicone, so there's not a whole lot to them. Looks like they're sold out now. I did put a link to them in the description for this video, but apparently you can't get them right now from this company. They are plenty available all over the place. But now what I want to do, now that I have kind of a rigid mount here, you know, it does have some give to it, but not a lot. I want to do a mesh leveling routine on the bed so that I'm pretty sure that it's not going to move too much. You know, with the springs in here, you do have the possibility of the bed moving back and forth, and there's some vibration in the bed through the springs. I have less chance of that now. There still is that there because the silicone isn't completely rigid. So there is still that, but now when I go to remove parts, I already had the removable bed, but sometimes when you remove parts, you can get the thing out of whack when there are just springs holding it up. So it's just a little more rigid. So I'm looking for more rigidity out of the printer as a whole. But now that it is more rigid, I have the option of I can go in here, and I still do not have automatic bed leveling sensor on here. I think that's what we'll do Thursday, is we'll put a BL Touch on here to go and detect the height of the bed. But I want to show you a way that you can get the same effect without having the actual sensor, just with the code, the firmware. So we need to be able to modify our firmware. So that meant that we need to update our firmware. This particular printer, the Ender 3, and there might be others, some of the ANET printers might be this way, but the Ender 3 with the 8-bit board typically does not have what's called a bootloader on the board. So that means that in order to do any of this, in order to change any of the firmware that well, this is the LCD screen. The firmware is actually on the motherboard down here, but pointed to the LCD screen because that's where you see it, I guess. To change any of that, I need to add what's called a bootloader. So a bootloader is just a little tiny piece of code that lets you add, well, it doesn't just let you add firmware, but you can't add firmware without it installed. And just to save memory space on these Ender 3 boards, Creality didn't put a bootloader on them. So there's a process. So if you don't know if you have a bootloader or not, you can just try to skip the step that we're about to do. And if it works, then that means that you do have a bootloader installed already. Again, if you have a 32-bit board, then this is not the way to do to change your firmware. We'll have to look at that a different way. We'll look at that next week sometime. But if you have the older board, now this is not necessarily an older printer. I bought it in November, but it is the older board, and we'll look at the board down here, so maybe you can tell if you have an 8-bit or 32-bit board if you don't know. But in order to do this, we need to get a couple of things. One of them, we're going to need our Arduino. Just an Uno will do. We're going to need some of these kind of, well, it doesn't have to be this kind. You have to connect some wires. So I've used these wires. So I used this kind with female on both ends. And then for these 5 that are all ribboned together, that's what they are. And then the yellow one over here is female one end and male on the other end, because it needs to do a slightly different thing. We're going to use the Arduino to add a bootloader to our Ender 3 so that we can actually update the firmware. Now, once you do this, once you add the bootloader, your printer won't have any firmware. So be sure that you are ready to do the entire process, or else you'll have a printer that can't do anything. Once you get to the step when we push the button to put the firmware on, your printer won't do anything when it put the bootloader on. Your printer won't do anything until you have actually added firmware. So make sure you've got all that ready. I'm going to go what I think is the easy route, and I'm going to use TH3D's unified firmware. So if you just do TH3D UFW as a search, it should take you to the unified 1 firmware package. I'm using 1. It'll tell you that there is a 2, unified 2 firmware site. I'm not going to use the version 2 on this printer. We might do that on once we get a 32-bit board on there, but we're using, again, the 8-bit board, and we're going to use the regular one, download latest firmware. Now this is like a 500 megabyte download, and their site yesterday when I downloaded it was a little bit slow, so it did take quite a while to download it. I've already downloaded it though, and it's a zip file that you unzip. This will have what we need to install the bootloader and the firmware itself in this one package. It'll come with a version of Arduino that's already set up. You don't have to change a whole lot to get it to do what you need it to do as far as firmware and bootloader goes. You can use the regular Arduino IDE if you have that, but I just find this one a little bit easier. They've already gone through and set things pretty much the way you need it. I also like their version of the firmware for if you've not done a lot with firmware before, because they have it set up where it's pretty easy. We're going to have to change 2 lines of code, and by changing them, we're going to uncomment them, and that's it, and we'll have our manual mesh leveling. We'll also use this when we install the BL Touch as well. But I'm going to, so whenever you get to, there are plenty of firmware. You can go to the official Marlin branch on GitHub and get firmware from there. Again, I just like this one in particular because it's pretty simple to use if you've never done any of it before. And I believe somewhere in here they have a pretty good and still relevant video. I don't think it's this video though, about installing a bootloader. I think maybe if you go to this link, they will walk you through installing a bootloader. That's what I'm going to do as well, but they will, in case you miss something, they have that there also. So to install a bootloader, let's get our Arduino out of the way for right now because we have to get into our printer. So let's rearrange some stuff. Let's see, I guess I lost one of the springs. There we go. Let's unplug it from power. So just unplugging it from power. For one, I need to turn it on its side where that plug-in is, and you're going to be working on the motherboard, so we don't want it to be powered accidentally. So we need to get right here. Now there actually is one of these screws. See if I can get it to sit in a stable spot. There we go. There is one screw on the top side that we'll need to remove also. I'll go ahead and do that. So there it is. And then these 3. If you have a slightly older than this, like you bought it before this one, Ender 3, these screws are on the top. All this whole thing is flipped up the other way. So it's upside down to this. The idea is the same, just you might have to remove some different set of screws to get to the motherboard. So there we go. It's got a fan connected. I'm just going to leave that there. You probably should disconnect the fan just so it's not dangling out there, but I left it there. Let's see if we can get in pretty close here, because we need to see in there. And maybe zoom in. We're almost where we can see, but there we go. We need to see those pins right there. Other things you can look at here. Let's see if I can make it not shift focus. You can see your board revision in here. It's hard for me to see it, but down here under the ribbon cable, there it is, version 1.1.4. Those are the 8-bit boards with the version 1. I think the 32-bit boards are version 4 something. I don't know the other numbers associated with it, but version 4 would be one of them. They look similar. Here's the little main processor right here. These are controlling our stepper motors. They have these wires are going out to the stepper motors. There's tiny little potentiometers right here that you could use if you've ever heard somebody say you need to adjust your VREF. That means turning these little potentiometers. Don't do that unless you know exactly what you need to do. You need a multimeter. You need some way or some way, which is probably a multimeter, to measure what voltage is actually on those things. The only reason I would do that, try to modify the VREF, is if you're printing and you're getting bad prints in kind of inconsistently, and you touch one of the stepper motors and it's really, really hot, or you're constantly getting skipping on your extruder. Maybe you're not, your extruder just seems underpowered. Maybe that would be the time. You've tried everything else. Maybe that would be the time to go in here and adjust the VREF, so the voltage reference on these drivers. Otherwise, it's probably not a good idea. You could check you know, just look at things. Like if one of these heat sinks falls off, then that could be a big problem. It might have already been a problem that you can't recover from, but these are actually attached pretty well. So I have seen some boards where the heat sinks are not attached very well, or maybe you attach them yourself, and if they come off of there, then there's a good chance that that driver is going to have problems if it didn't burn itself up already. Anyway, we don't need to do any of that. We just need to get to those little pins down there. I'm going to have to build a little scaffolding so that we can get our Arduino up high enough. Where'd I put the Arduino? There it is. All right, so let's look at the Arduino for a second. So it's down here. It has a similar set of pins, exactly the same set of pins. This is the programming header, and I don't know that you need to exactly know what pin is what, but let's see. We'll go ahead and walk through them just so in case you're curious. They have the same pin layout on the Arduino as they do on the motherboard for the printer in this orientation. So if they're, well, let's have to zoom out, won't we? So if I line them up this way, then the pin out is the same in this orientation between the Arduino and the board that you're working on. Oh, yeah, assuming you're working on an Ender board. Now, another board is going to have a similar set of programming pins, but I'm not 100% they'll be in the exact same order on other boards. They probably are, but I don't know that. And so what you have is where I've got the green wire here in the corner. That is the MISO, the master in slave out pin. The purple one on the right beneath that, that is your volts, 5 volts. I think it's 5 volts. It's your voltage. I don't know if it's 5 or 3.3. I assume it's 5. The blue one here in the top middle, get the yellow out of the way. Top middle, that one is the clock, the serial clock. Underneath it, I've got, and the colors don't matter, right? They're just wires. The gray one here is, what is that one? That's the MOSI, so that's the master out slave in pin. The white on the bottom left corner, that's the ground. And then this one that I don't have plugged in on the Arduino, that's the reset pin. I'm actually using the reset, it's going to be pin 10 over here, and that's why I needed a different wire. I needed this one to have a pin on it. These all had receivers on it. And all you do, it's hard to do because it's up inside. If you have the board still mounted in the printer, it is difficult to get in here. But all you do is you plug the wires in the exact same order on this one. So I might get all in the way and you can't see this very well. But what I'm doing is I'm taking these wires and plugging them into the exact same order that they are here. So I have white in the bottom corner, then gray, and again the colors do not matter. The colors are just there so that I can kind of tell what wire is what. Then I did purple. Then I'll need the yellow wire that's going to be the reset pin, except I'm using the reset on the Arduino as pin 10 on the digital side. Wow. There. Then I did blue and then green. Nope, I missed. We can just get the last one. All right. So it's going to look something like that when you get it done. So I've got plugged into the Arduino, and then plugged into the printer board. Now if I get a USB cable, we can get our first glimpse of if we've done this correctly or not. I'm going to plug this into the computer. Oh, all right, so this is looking promising. We have, well, on the Arduino, you have a green light that comes on, this saying it's powered, but we have a light on our board. So that at least means that we have power, so the power and ground are hooked up correctly. Doesn't necessarily mean that we've got the correct order on every other wire, but at least we have these powered and ground, and we have power to our board. Your screen, if your LCD screen is connected, so the LCD screen is this ribbon cable here, going off to the bottom of our screen. If you have that connected, then your LCD will be on also. You do not need power on the printer. The main power from the wall doesn't need to be on. In fact, I wouldn't have it. I already told you I unplugged that. All right. Now what we do is go over to, this is the file that I told you to download. This file, extracted, and it's in a folder. So here are all the files that come in. They have some bed level STLs. They have a whole bunch of things in here. These EasyAble, they have their own version of automatic bed leveling sensors and everything, and mounting and everything. So some of this will be particular to that setup. But what we need to do right now is open firmware windows.bat. So they have a little batch file that will open Arduino the correct way for programming the printer. So this is their firmware, and this is what it would look like pretty much in any other version of Marlin 1. We're doing Marlin 1.0 or 1 point something, where you have a whole bunch of tabs. You know, there's a whole list of, well, it's off your screen, but there are many little files. Most of the time, all you're working on is the one called configuration.h or the configuration advanced.h. Those are really the only two that you ever work on. Right now, we can't do that though, because we can't upload firmware. Actually, this printer I can upload firmware to, because it does have a bootloader on it, but most printers, most Ender 3 printers that are 8-bit boards don't come with a bootloader. So this is what we're doing. It's going to install this bootloader. We've wired it up 1-to-1 between the Arduino and the board. And if we go into this same thing, but we go to File, Examples, this is one of the reasons I like theirs, is they've got Arduino ISP. So that was in File, Examples, Arduino ISP. It opens this bit of code, and so you can see there's the MISO and the serial clock. That actually shows you the wiring diagram. It does give you a warning if you're on not an Arduino Uno, if you're on a 0 or a Due, whatever that is. I guess those are different versions of Arduino. Then these are different pinouts, I guess. Anyway, here's a little program. We don't have to know anything about how this is going. This does show you right here that, remember, we hooked our yellow wire to pin 10 as the reset pin instead of going off of the reset pin on the programming header for the Arduino. Here are the other pinouts. You don't really need to know any of that. What you need to do is, at this point, this is the program that we are going to set up on the Arduino to be able to burn the bootloader. All right, so we do need to go in and make sure we have our board set to an Arduino Uno, assuming that's what you're using for the Arduino. That's what we have over here is a Uno. We need to set the COM port that it's on. Looks like it's COM 7. Yours will totally be a different number. Don't expect yours to be also number 7. So we'll select that. I always like to go back. Oh, yeah, I did check it because it goes off of there. You might think that, oh, it's time to burn the bootloader, but not yet. We have to load some code onto the Arduino first. So that should be everything we need. We need to upload. This does not do anything to the printer. This is uploading code to the Arduino. So it's down here in the bottom, it's compiling, uploading, writing. All right, now our Arduino is ready to code a bootloader onto our printer. So we can close this window, or it's set up as an ISP, Arduino ISP. Now we are back to the window that originally opened when we ran that batch file over here. When we ran this batch file, this was what originally opened, because that's normally what you're going to do, is you're going to edit the firmware. All right, so I'm back over here. I'm still not ready to upload the firmware yet, though. I still need to actually burn a bootloader. So now, leaving the Arduino connected, because it's going to do the work of putting the bootloader on the printer, I'm going to go in, change to, now the board I want is this Sanguino 1284P. So if you're running off of regular Arduino IDE, you might have to go download a, I don't know, a codec or a batch file or something to actually let you, an extension, probably some kind of extension. Do that. That's one of the things I like about using the TH3D, is that they've already got exactly what you need in here, and they don't have much else, so they don't have a lot of extra stuff in here in the Arduino side of thing. Arduino did not change COM ports, so I'm going to leave that. So all I've done is change Sanguino. The processor, there's only one. If you're in the Arduino IDE, then there's a whole set of these. You need to select this one, the 1284p 16 megahertz. Programmer, again, if you're using their package, it should already be set to Arduino as ISP. If you're in the Arduino IDE from Arduino, then you might have to go select Arduino as ISP. This one's already selected. And now we should be able to do burn bootloader. I suppose I'll do this. It's a little bit risky, but not risky, but it will mean that we have to put firmware on here, which is fine. So burn bootloader, and it's done. AVR do done. Thank you. Let's look in here. So it didn't take any time to burn the bootloader. It's really fast. Now if I look, let's go, actually, my screen didn't go blank. Let's unhook our Arduino, unhook all of this. Actually, no, let's not do that, because we need to put firmware on here. I wanted to show you, I guess, all right, this might be a little shaky, but let's go around here. So this is what your screen will just be blue. So you may not have anything on your screen at all, and that's okay. That just means that you have a bootloader now, but you have no firmware. So let's put some firmware on it. Now, what I wanted to do, the whole point of this was I wanted to be able to do manual mesh bed leveling on the printer, which is not automatically enabled on this Ender 3. Now, I can do a lot of other things as well, but I wanted to do that. So let's, all right, I got to get that out of the way so that we can get into our configuration file. So the way this TH3D unified firmware, what they mean by unified firmware is that all the stuff you need for a lot of different printers is built into this one thing. So they give you a, whoops, wrong one. There we go. They give you a how to read this. I'm in the configuration.h file. That's where you do most of your work. You might do some in the advanced. Every now and then you might venture off into one of these others, but that's for very specific things. So pretty much you're only in the configuration.h and configuration advanced.h. So how to use this firmware, read this, actually read this. All right. This is how you do most of the editing, at least at the beginning, is they've got most everything uncommented, so where you can't, it is not active in the code. And in the Arduino language, that means there are these two / marks in front of the code. And I'll see if I can find one. There, see this? If I wanted this to be, now this is just a row of equal signs, so I don't actually want that uncommented, but I would just erase these two / to make that line an active piece of code. So they're giving you a reminder of that. They do remind you that if you have Cura, Slicer, Simplify 3D, anything like that. Now, I should have reminded you that already. If you do have Cura open or any of these other slicers, most of them are going to take over the COM port for your printer, and you're not going to be able to connect the Arduino to it. You're not going to be able to do a lot of different things. Now, in this case, the printer is not directly connected to the Arduino. In fact, we can go ahead and disconnect it and connect straight to the printer. We don't need the Arduino anymore. So I'll let you see what I'm doing over here. There we go. I'm just going to unplug all of these, get it out of the way, get my little scaffolding out of the way. Don't forget to remove the filament spool if you have to turn your printer upside down. I forgot that the other day and filament went everywhere. Alright, let's see if we can get this kind of screwed back together so it's not falling apart on us. Since it is upside down. That's kind of crooked in there. I'll have to fix that. On this particular printer, one of these screws is longer than the others. They're all the same thread, but one is longer. This one's giving me problems. The longer one goes at the back there. I should not probably have tightened all of those down before putting this one in. That's probably going to create problems. Can't really see where the hole is. There it goes. And then there is the one on top up here that you didn't see before. So now our printer, it doesn't do anything, but it does have a bootloader. And again, if you have a 32-bit machine, this is at all not necessary. It's already has a bootloader. I don't know of any 32-bit machines that don't already have a bootloader on them. Of course, this is giving me problems too. There we go. Put our filament back up here just so it's not in the way of everything. It is all tangled up. There we go. All right. And now when we turn our, well, we got to plug our printer back in, don't we? When we turn it back on, our printer won't boot up. So let's get the USB cable for our printer now. You don't, again, you don't have to have the power, the main power on. In fact, I'll turn it off because it's going to get, the screen and the motherboard are going to get power through the USB cable right now. So all I've done is plugged in the USB cable here. All right, back over to our coding. Again, what I was saying is if you had already done the bootloader stuff, or you had been in Cura or Slicer or whatever, and then you went to go over to Arduino, then that COM port that your printer is using is being used by Cura, and you won't be able to do this. You'll get errors. So close Cura, close Simplify 3D, Slicer, Prusa Slicer, whatever you have open. Close all of those, and then you can do the firmware updating. All right. So since this is an Ender 3, the way this firmware works is I just search for Ender 3, and there it is. Now this one, when it would start like this, it's going to be like all of the printers, and there are Ender 5, Ender 2, Ender 3, other printers, not Creality. There are a whole bunch of printers that have this same setup in here, where they're all commented out, and you pick the one that matches your printer. So since we have an Ender 3, I search for Ender 3. Control F is what I typed on the keyboard to do a search, and then I uncomment this. You can even see that the define changed to green, showing that it's active. It's a command. And now all of this, there'll be somewhere, probably not right here, but there will be conditional statements in other parts of the code that say if Ender 3 is defined, basically, then do all these things. And this is one of them. Now here they have all of these are different probe mounts for if you have the automatic bed leveling system like the BL Touch. We don't have any of that. What I want to do is I want to enable manual mesh bed leveling. So I'm going to Control F again and just search for manual. It's probably underscore mesh. I don't remember. There it is. And again, this one would start with it commented out, and you would search for manual mesh leveling. Most all of the, and maybe all of them, I don't know, but certainly most all of the commands, all the options in this packaged firmware give you a definition of what it is and some other resources to go along with it. So to activate it, you uncomment it. There are a lot of other things. Now at some point you turn on too many things that the code, it becomes too large and it can't all fit on your printer. So you do have to be careful. In fact, it will show us, once we load this up, it'll show us how much of our printer's memory we're using. So those are the only two things. That is editing the code. Picking out which printer you're using, so uncommenting the define statement for Ender 3, that tells it that this firmware needs to go on to Ender 3, and then turning on the option. There are other options enabled also by default. This one is not enabled by default, and I did want it enabled, so uncommenting manual mesh leveling, and that's it. What we do now is, well, we do need to check Sanguino, and port is now 8. So we were 7 before because that was actually the Arduino. This printer usually comes up as COM8 for me, so it has done that. So we selected our board that the printer is using, the Sanguino, and the COM port that it's on, and then we can upload. This will take a little bit longer because there is a lot of code to compile than it did for the bootloader stuff. It has to compile all of, I don't know how many little pieces to this firmware there are, but there are a lot of them. Again, this is not how you do it on a 32-bit machine. We'll look at that hopefully next week when we have a 32-bit board on our machine. This is for the 8-bit boards. So it's still compiling. I still have nothing on the printer screen. Oh yeah, in the chat there are other options for manual mesh. So this is, I'm just taking the default options here, and it's going to do a 4x4 grid when I do this. So this one, what I mean by the grid, you'll know once we actually do the manual mesh leveling, you'll see what the grid means. But basically it's going to probe on the bed, sort of probe, we're going to figure out how high different points of the bed are, and then we will map the bed. And so a lot of the options for that. Here we go. Uploading, writing. Let's see if I can make this larger. And it's done. And on our screen, well, you can't really tell, but I have information on the screen. It's not blank anymore. But again, what I was saying about the options is there is another one of these files in here, that you can go in the configuration.backend control manual mesh. Let's see, find. See if we can find some of the options for it. Just going off. You have to find for the way that they have it set up, you have to find the correct combination of if enabled manual mesh. So we have that, and disabled easy enable, and disabled Wanhao. So this would work for us. Then we could define the step size, how far the Z is going to move up and down. So what's the resolution basically? The maximum points on the grid in the X and Y directions and all this kind of stuff. We're going to leave all of those. The default settings are good enough for what we need. And so we're not going to go in and change any of those, but they're every little thing you can think of to change is available in here somewhere. It's just a matter of finding it. I clicked on something, so I don't know what I actually clicked on there. All right, so we have firmware. So let's close Arduino. We don't need that. We don't need this. We don't need this anymore. We'll leave it open though. All right, let's go and actually do manual mesh leveling. So we gotta, now that we can do that, we need to see it. All right, so first thing you need to do is you do need to heat everything to printing temperature. So I'm gonna preheat for PLA. Uh-oh. All right, I'm gonna shut down and restart. You got it was let me restart. I was trying to preheat with no power on, so it was only being run by the USB cable, and you know, obviously that's not going to be enough to heat anything, so it kind of went crazy there for a second. All right, let's try again. Prepare preheat PLA. There we go. So if you don't have your nozzle and bed heated to your printing temperatures when you go to do any of this stuff, particularly related to the Z height or leveling or manual mesh leveling, any of those things, then it's almost pointless, because as soon as you heat it, unless you're printing with a cold bed. Now if you don't heat your bed to print, then that's okay. But if you print with a heated bed, then you should level and trim and everything with the heated bed also, because the bed is going to warp due to heat, and it'll warp differently at different temperatures. So you should probably print or heat this to the temperature you're actually going to print at to get the best results from it. You'll need a sheet of paper or something like that. We'll use a sheet of paper. It's pretty simple. In this case, a lot of times I use a strip of paper, but in this case, it's actually easier to just use a full sheet so that it kind of covers the whole bed at once. I will go ahead and mention while it's heating up, I changed the springs, right? That changed the height of this bed. So if you do something like that, don't forget that you probably need to adjust the height of your Z sensor. You know, where is it hitting, where is it going to trigger at? once we install the BL Touch, that will be the Z height sensor, so we won't need to worry with moving this up and down anymore. But this process is all stuff that, assuming you have an Arduino and a couple of wires, you can do all of this for free, other than it takes your time to do it. All right, we're up to temperature. So here we go. In my menu, prepare, bed leveling, level bed. So it's going to go through and home. Okay, click to begin is what it says on the menu. So there's 0.1 of 25. So what I'm doing is I'm adjusting the knob here to raise or lower the print carriage until I feel just a right amount of drag between the paper. So I can move it back and forth pretty easily, but I can feel some grabbing between. Oh, make sure your nozzle's clean and you don't have a big blob of filament hanging out of the nozzle, because that would obviously affect the height measuring. This one I'm actually having to lower. When it buckles the paper like that, that's too close, so I need to raise it a little bit. That one's way too tight. See how it's buckling? That one's not buckling, but it's way more tension, or not tension necessarily, but this one's, that corner's way lower than the others. Oh, I didn't do this already, or I've done it already. I didn't do it on camera. You should level the bed as, you know, by the 4 corners first before doing this. I had already done that. So what this is doing is it's basically figuring out how far below or above the average point each of these 25 points. So I'm doing a 5x5 grid. I think I said 4x4 earlier, but I think it's 5x5. And it'll use this data to create a virtual map of the bed that, as it prints across the bed, it can move the carriage up and down to kind of trace the bed. See, I've got a high spot right here. It's really grabbing. And that's also high. It won't be perfect, but it will be pretty good. And you can obviously, this was way high. Wow. On the last row. Again, it doesn't make a huge difference if you're printing small parts, but if you're trying to print parts that have a footprint that covers a lot of the bed, then something like this is almost necessary. You might get away with just a glass bed that's more or less flat on its own, but if you don't have that, all right, then this is one way to deal with a bed that might have warped across it somewhere. All right, so now it's done that. I need to save that. So store settings is also in here. There it goes. Now, to check that I've actually done something, you could run a print and kind of lightly touch the Z stepper coupler back there, and you can probably feel it kind of it doesn't move a lot, but moving tiny bits. But what we're going to do is we're going to go into Pronterface, which I have already shown you before, but let me open it up. So we're going to go in here, and we're actually going to talk to the printer, and it's going to show us it's not going to show us a map, but it'll show us coordinates. We can plot them though. So we're on COM 8, connect. Oh, plug in the USB cable. Usually helps with these things until we install Octoprint anyway. There we go. In fact, there is this data right here. That is the bed data. So the mesh that corresponds to the bed. It's not in a convenient format right there, so I'm going to do M420V. So that is going to report the verbose information of the bed data right here. So this is all of the little ups and downs. It looks like they're all positives from where it thinks Z0 is. I want to copy all of this and then see if we can find a good, this one is the one I like to use. So this is, can you see the web address up there? Nope. There it is. Lockspace.eu, and they've got some sample data in there. We'll delete that, and all I did is Control C over here. So I highlighted and copied the data from our printer, Control C, and then I deleted their data and then put Control V, so paste the data over here and visualize, and there's a map of our bed. So it looks like, you know, that, and I said that corner, that back corner where the heater wire comes in, I said that one's really high. We could probably lower that one a little bit manually with adjusting the knob, that how much we've compressed that silicone standoff. And we could probably get this flatter. You can see though, like there's a kind of hump. Now this is exaggerated. You know, this scale right here, this is 0.5 millimeters. So it's, you know, it's half a millimeter. So it's very much exaggerated from what it really is. And that high corner is, you know, just over half a millimeter high. But we could probably get it a little bit flatter. But if we don't, now the printer, when we go to slice stuff, we can tell the slicer, well, we can tell the processor to adjust for these irregularities in our bed. We have to do that though, so I need to open up Cura, because all of this doesn't do anything if I don't tell the file I'm about to print to actually use the mesh data. So we need to do that in Cura or your slicer. I should have already opened Cura. It's slow to load, so take us a minute to get it going. Let's see what else has been. I finished the violin print, so I put the picture of it in Discord. I don't have it out here, I don't think. Nope, it's not out here. Finished it though. It actually plays. I don't know how to play the violin really, but it was a cool print, and I think I will bring it out, not today, but I'll show you things about it, because it's a good example of just because you're 3D printing something doesn't mean you have to 3D print everything. So it has like a carbon fiber tube to reinforce the neck, and it's got mechanical tuners that I just bought off of eBay or Amazon, I don't remember. And it's got a, you know, a standard violin bridge and strings. So it's a good mix of printed parts and regular parts. All right, so we're finally Cura opened. And if you just click up here, manage printers, and then we're on our Ender 3. I've got a TiVo Tornado in there. That's not what we want. We want the Ender 3. Machine settings. So in here, let's see if I can make this window a little bigger. Guess I can't make the font any bigger. But over here, this is the start G code, and then obviously the end G code over here. This is code that gets added to the beginning of any file that Cura is going to slice. Every one of the slicers has something like this where you can edit the beginning and ending code manually. So what I did is, you can see right here, after you do G28, so G28 is the home X, Y, and Z, so it does all its homing routine. After you do that, you go in and write this little line of code, M420. So again, I used 420 on Pronterface. I used 420V to get the verbose information. Here, I'm doing M420 S1. So this switch is either 1 for on or 0 for off. You might can just type S, I don't know. But S1 is on. So the 420 talks about the manual mesh data. And then switch 1 is on. So use the manual mesh data. So now, as long as I have this line in here, then the printer will know when it reads this G code that, oh, I'm supposed to load up all the mesh data and adjust that first layer. I can change other things here where there are a couple of other options. There's the option to fade out. So I can do, I think it's Z. Let's see if I wrote it down. I didn't write it down. I think it's Z, and then a number like 3 or whatever. And what this is the amount of fade. So in the first layer, it's perfectly tracing the bed. The next layer, it's not quite tracing the bed. And then eventually it moves to where it's not tracing the bed at all, the further up in the Z direction you go. We'd have to look at the actual commands. So do Marlin M420, and let's look at the Z. Yeah, it's the Z fade height. So it was Z. It doesn't tell me. I believe that's in millimeters. It doesn't tell me if it's in layers or millimeters here, which units are important, but I think it's in millimeters. Most of the measurements are in millimeters and not layers. So I believe it is in millimeters. And above whatever you put in there, it doesn't anymore compensate for the bed being warped. By some amount of layers, you've kind of leveled everything out at that point, and you don't need to worry with your Z motor constantly moving up and down across a layer. And it doesn't take long. Just get the first 4 or 5 layers compensated, and then after that, you're probably fine to turn off the bed leveling mesh data. All right, let's see. There's a couple of other options here. Well, we can load the mesh data. I don't know that you actually need to load the mesh data. I think it automatically does that. Oh, yeah, we could. Yeah, I don't think you need to do that. T. Oh, that's if you're trying to print it out, and then we use the V. Okay, so the Z fade is disabled in the TH3D firmware. I've never bothered with it anyway, but apparently it is disabled in the TH3D firmware. And now we have, it took us, what, an hour? A little under an hour. And we went pretty slow. We walked through all the little steps pretty slowly, but now our printer, when we go to print, or yeah, assuming we use this Cura, I should close this, assuming we use Cura, then the prints that come off of it will adjust for the unevenness of our bed automatically. We don't have to go, unless you jostle the bed around significantly, you don't have to go and redo that manual mesh leveling with the paper. It just stores that data. If you ever do anything that you think has changed the shape or the position of the bed, then you need to go redo all of that and generate new mesh data. It is a good idea to go in here to Pronterface or something like that and check that it actually did record and save the data. I have not turned it off. In fact, why don't I do that? Let's close Cura. Let's turn it off. Look at some of these 075, 125. Oh, and it's still going to get power. I'm going to let it completely shut down, and then we don't need to turn the whole thing back on. Let's reconnect. Yeah, So it did save all of our data. This data here after a power down is the same as the data was before the power down. So it did save it. So it is easy to forget to store settings. You can store settings from here also. M500 store settings. So you could do that to store settings. I use the menu on the printer itself to store the settings. But now we have a printer that has manual mesh leveling. It didn't cost us anything, assuming I had an Arduino Uno and a couple of wires. So we did, and you can do this without putting the solid standoffs in here. You can keep the regular springs, and it still does the same thing. I just want it to be a little more rigid. You could print your own standoffs, I'm sure, almost positive, without looking, but let's look. That Thingiverse is going to have printable standoffs. Let's see. Maybe not. Camera mounts. Well, they're just cylinders, so there's really no reason that maybe I'm searching for the wrong terms, or Thingiverse doesn't have a great search engine. It wants exactly the terms that you input. Well, I'll look around and see. I'm sure, because you could easily make these bed mounts, so I don't know why I can't find them. Well, they're just cylinders. I'll look and see if I can. Hey, there's a kit. It's for a CR10. That would work for an Ender 3 also. But there, you can print your own. It even has one set that's adjusted to be the strain relief on the bed heater wires. And you can see them under that. Oh, you're not seeing what I'm seeing. I was searching in Thingiverse to find these, basically. And there you can kind of see one in action. The only thing with printing your own version of these is that you do have to make sure that it can withstand the heat, because if your heated bed is going to be, you know, most of the time you're probably not going to be above 60, but 60 gets really close to PLA's glass transition temperature, depending on the blend of PLA that you have, and it might they might deform, which would defeat the whole purpose of having a rigid bed, right? So print them in PETG or ABS or something like that, or don't heat your bed, or buy your own, or just don't use them at all. Use the springs that come in here. If you're using springs, then one thing I would suggest is tighten them down as much as you can. So compress the springs as much as you can. At some point you can't compress them any further, because it begins to your Z trigger is, you can't go low enough or high enough, or you can't move it in the right position. But don't leave your springs really tall here if you don't have to. And that by itself, just compressing those springs, will help eliminate a lot of the vibration in the bed. All right, I think that gets us a good amount for today. Next time, I am going to add in ABL, so that's automatic bed leveling. I haven't put anything in there yet, but that is, we will install a BL Touch on here. We'll add the firmware for making it work with this printer, with the 8-bit board, the board that came with it. Most of the steps, at least for the BL Touch, will be the same, but if you're on a different board, then how you update the firmware will be different. We will get to a 32-bit board. I don't have that listed next week, but I think I will go ahead and put a 32-bit board next week, so that, because I know a lot of you have Ender 3 version 2, or even an Ender 3 that has a Pro, maybe, that has a 32-bit board in it already. And it uses a different, we're not going to use Arduino, we're going to use Visual Studio, and we're going to not have to communicate over the USB cable. It works a little bit differently on how to update it. It's not as bad as it used to be. So if you've been afraid to update your firmware, or you don't know how to compile it with this Visual Studio stuff, they've made it a lot simpler recently, and it's about as simple as what we just did with the Arduino. You still edit the configuration files, and the used to be the compiling part was cumbersome and you didn't really know what to select here and there. They've streamlined a lot of that. So we'll do that. We'll do that next week. I'll go ahead and put it in for one of these. I think we will print with some flexibles though, because that's fun. And maybe we can throw in some of these others as little short pieces and just add in a 32-bit board next week. All right. I'll jump over to Zoom in case anybody has questions from there that they need answered. And I will see you guys on Thursday.